everyone. Welcome to the assignment number 2 of the distributed cloud computing. We are the 5 group members. My name is Hamza Jawaid, and the topic for the assignment number 2 is the cloud computing reference architecture and the use cases. Now, according to the NIST cloud computing reference architecture, there are 5 major actors. Each actor is an entity that can be a person or an organization. So let's talk about the first actor. Now let's talk about the first sector of the cloud computing. That is cloud consumer. It is an ultimate stakeholder of the cloud computing services that uses the cloud services. Cloud consumer may request services from the cloud provider or from the cloud broker as well. And the second actor is the cloud provider. Basically, cloud provider is responsible for providing the services to their users. Some of the top cloud providers in the world are the Google Cloud, AWS, Oracle, IBM, and Microsoft Azure. And the third actor is the cloud auditor. It is a party that conducts the independent assessment of the cloud services. Auditor can evaluate the services provided by the provider in terms of performance, security, privacy. And the fourth one is the cloud broker. It is an entity basically that manages the use, performance, and the delivery of cloud services, and sometimes they also do the negotiation work between the cloud provider and the cloud consumer. And the fifth and the last actor is the cloud carrier. They are used to provide the connectivity of transportation of services from cloud provider to the cloud consumer. Here the interaction between the actors in the cloud computing is given. The cloud consumer can take the services from cloud provider directly or via cloud broker, and same as the cloud auditor may get information for the cloud consumer and the cloud provider for the auditing purposes. There are the major activities of the cloud provider: service deployment, service orchestration, cloud service management, security, and the privacy. And according to NIST, service deployment is further divided into 4 parts, that is public cloud, hybrid cloud, private cloud, and the community cloud. Here are some examples of the usage scenario of the cloud consumer and the cloud provider. They are the software as a service, platform as a service, and infrastructure as a service.
What is cloud computing use case? Cloud computing use case describes the consumer requirement in using cloud computing service offerings. Later, we will dig into 2 main types of use case. Analyzing those 2 provides an intuitive perspective in serving existing standardization effort and identifying gaps. The first one is business use case. Those use cases help us to document the key technical requirements for USD cloud-related standards in the area of security, interoperability, and portability as required for the formulation of this roadmap. Another one is technical use case. Those use cases are technical in nature, capturing the more generic and cross-cutting technical requirements of cloud consumers. They are a description of how group of users and their resources may interact with one or more cloud computing systems to achieve specific goals. About deployment scenario perspective, there are a bunch of deployment scenarios, and we can summarize those scenarios into 4 components: centralized versus distributed, within versus crossing trust boundaries. Centralized integrated with within trust boundary requires simple consumer provider authentication and virtual machine management and so on. About centralized integrated with closing and trust boundary require SLA in support of government's requirements like national or regional regulatory compliance, something like that. Those each situation present different standards. The distribute integrated with within trust boundary requires to implement the P2P service discovery, P2P SLA and performance monitoring, and so on. And the distributed integrated with crossing trust boundary requires to implement the P2P SLA in support of governance requirements. For example, if we face situation to handle single cloud deployment, based on this analysis, we know those scenario 1 through 4 cloud in fact be deployed on either private cloud or public cloud. Hence, the different standards noted in deployment case centralized plus within trust boundary and centralized plus crossing trust boundary will be required.
Hello, my name is Deborah, and today I'm going to be talking about cloud computing reference architecture. So, on this presentation, I have two objectives. I'm going to be talking about the cloud broker, the cloud auditor, and the cloud carrier. And I'm going to be talking in depth about this with their interaction with the cloud consumer and cloud provider. And also, I'm going to talk about the scope of control between the cloud provider and the cloud consumer. So, let's get into it. So I'm going to start by talking about the cloud broker. So this is just an entity that manages like the use, performance, and delivery of cloud services. And this diagram just shows like the interaction between the cloud consumer, the cloud broker, and the cloud provider. So a cloud consumer can directly like request a service from the broker without going to the provider, and then the broker may create like a new service by combining like multiple services or enhancing like an existing services and then provides it for the consumer. So this is an interaction that a consumer can have without going through the provider but just going directly to the broker. So a cloud broker can provide services in three categories, one being the service intermediation. A cloud broker, in this case, a cloud broker just makes a service better by knowing certain parts of it and then adding extra helpful things for the people who use the cloud services. So it's just like an intermediator, because it would also mean that it makes it easier to use the services by keeping track of who can use them, showing how like well they work and making them safer and more. So it's just like an intermediate. And then we have a service aggregation. So in this case, a cloud broker combines different services together to make a new one, and then it takes data from different places and make sure it moves securely between the people who can use the cloud services and the companies that are providing the services. So yeah, that's aggregation. And then we have arbitrage. So service arbitrage is like service aggregation, but the broker isn't limited to the specific services. So what am I saying? It's just that for arbitrage, you can have the freedom to pick the services from different places. And I can give an example. For example, a cloud broker might use a service that rates like how trustworthy like different companies are, and then from there it can choose the best one for a particular task. So that's how different it is from the aggregation. So next on we have the cloud carrier. I'll say this is like a delivery person for the cloud services, because they make sure that the services that we use online get from the companies that provide that to you. So when a cloud provider, let's say like a big company, gives you a service, they have to agree on how well it should work with both the carrier and you, the user. So they set up a special deal which is called the service level agreements, which is also referred to as SLA. And they set up this agreement with the carrier and with you, the user. So sometimes the provider might ask for, like, let's say, a special connection to make sure that everything runs smoothly and securely whenever they're transmitting. And then they might even write like specific requirements in the agreement with the carrier to make sure that they meet all their promises to you. So it's just like a delivery guy, but with so many promises that, oh, I'm securely gonna provide everything in a secure way. Um, and then we have cloud auditor. So an auditor is just someone who checks on the cloud services to make sure they are safe and working well. They look at things like security, privacy, and how well the services are performing. And this is important, like especially for government agencies who often use like rules saying that they might check the security for the cloud services they use. So whenever someone is auditing like the security, the auditor checks if the security measures are in place and if they're working correctly. And they also have to also make sure the services follow like the rules and the policies about the security. So it's just auditing, like it's just from the definition, auditor, a cloud auditor is just like an auditor. So they also have like privacy auditing, where the auditor has to check if the services are following like the rules and the laws and keeping people's personal information safe, so that they can keep the data in a confidential way and they're not sharing it with anyone without their permission at all. So they also have to like meet these legal requirements for the record. And then I would say, yeah, overall, like audits are just important to make sure that the cloud services are safe and secure and that they're following the rules of, let's say, like confidentiality and everything like that. And then so lastly, we're going to talk about the scope of control between the provider and the consumer. So in a cloud system, both the provider, like the cloud provider, and the consumer have like a say in how resources are managed. But this means they have like both control over what happens within the system as well. So the different types of cloud services affect like how much control each party has over these resources. So this diagram just like illustrates like the differences, like using a common software stack model, which has layers like of the application layer, the middleware layer, and the OS, which is the operating system. So by looking like at this breakdown of the diagram, it just shows like the control over like the different layers of the stack. Like if you see there on the arrows, they're like different weights on it. So this just shows like it gives like a better standing.
Hello, I'm Sartaj, and I'm going to talk about the architectural components of cloud computing. So first component is the service deployment models. There are four types: public, private, community, and hybrid. And private and community could be further subdivided into on-site and outsourced. So when a cloud infrastructure is operating using a public cloud, general people, that is, can actually access those services and cloud computing resources from a public network. Some examples are Amazon, Google Workspace, and Microsoft 365. When it's private, the cloud infrastructure is enclosed within the premises of an organization. So only the people within the organization can access those services and resources. And it's actually managed by the IT team of the organizations or maybe a third-party team. But when the private cloud is infrastructure is deployed on the on-premises data center, for example, then it's known to be on-site. But if we use a cloud provider to host our infrastructure, then it's going to be outsourced. In case of community, there are several organizations who have same goals and follow the same compliance and rules, so they can actually share cloud services between them without much hassle. So for such agendas, we are using community cloud services. An example is how healthcare institutions and research institutes are who follow the HIPAA privacy rules can actually use cloud computing services and share them by sharing different data and resources. So in this case, also there's if it's deployed, if the infrastructure is deployed within the community's data centers, it's on site. If it's deployed using cloud providers, then it's outsourced. Also, the cloud management here can be done using internal or external entities. When all these five clouds are sort of used together, maybe two of them or more of them, then we call it a hybrid cloud. An example could be how FBI has some secret missions, data of which are cloud resources of which are could be enclosed within a private cloud, but they again collaborate with different universities and forensic investigation teams where they might use outsourced community cloud or public cloud. Service orchestration is the automation of deployment, scaling, and management of the cloud resources and packages. It can be varying from the layers can be varying from different purposes to different purposes. And cloud service management is another component where the business support is provided. Let's say the pricing or rating, or how customers are managed, or how the system is configured, and how fast it can be uh, supplied to the service level agreement, and how those are managed, or how migration or portability is maintained. This management is usually done by either the cloud consumers or the cloud brokers. The last component is the security component, which is one of the most vital in cloud computing architecture. It has to be considered in every layer, the physical layer, the middle layer, and the top layer, which is the application layer. So we have to make sure the confidentiality, integrity, availability, and all other security components are kept in consideration in all those layers. We need to make sure that the software as service, platform as service, infrastructure as service, as they are actually catering to a wider attack surface. We need to make sure that we are aware of the fact that many entry points could be open from where attacks could be generated. So also, moreover, the different cloud deployment models have different security implications. For example, in public scenario, we need to think about how there are many different kinds of users and someone could intentionally or unintentionally make some security threats. And in private scenario, we need to make sure our perimeter is intact and there are no cybersecurity overlapping going on. That brings us to the point that cybersecurity is actually a shared responsibility. Broker or provider, consumer, everybody needs to be aware. So awareness programs are also very important, and also the cybersecurity trainings. And the providers have to make sure that they maintain good, solid privacy so that the data is protected and personal information or personal identifiable information does not get breached. So these are the important components of cloud computing architecture. Thank you.
I would like to thank my other friends for their presentations. In the first chapter, we started with what the cloud computing actors are, and we gave examples of each of them. Then we covered interactions between the actors in cloud computing. We tried to briefly summarize in which activities the cloud provider is used. Then also we briefly summarize in which activities the cloud provider is used. Then also we tried to give an example of usage scenarios for cloud consumer and cloud provider at the as a service level. In the next chapter, we tried to learn the business and technical use cases of cloud computing. We learned deployment scenario perspectives and tried to examine in detail the difference between centralized and distributed, within or without crossing trust boundary, and we gave examples about them. In the next chapter, we tried to explain in detail what cloud broker, what cloud auditor, and what cloud carrier are. We have seen the services provided by the cloud broker according to categories. Finally, then we learned the control scope of between provider and consumer according to layers. In the last chapter, we have seen architectural components in cloud computing reference architecture. Here we try to explain the four types of service deployment models: public cloud, private cloud, community or multi-cloud, and hybrid cloud. We try to give examples about these at the organizational level. We have covered service orchestration, cloud service management, and security, which are the major activities of the cloud provider in more detail. I would like to thank for listening us.